In this video lecture, we're going to discuss recursion and non-recursion. If say non-recursion, this is an iterative algorithm. So let's focus our discussion first with recursion. So if say recursion, the process in which a function calls itself directly or indirectly. So we use that function so iteratively so that we could solve the problem. And recursion could be implemented in solving Tower of Hanoi or TOH or tree traversal in order, pre-order, or post-order. And also it could be implemented in the FSO graph. And also it could be implemented in some sort of algorithm to um, to enhance it, okay? And also searching and factorial of a number and etc. So what are the properties of recursion? So first, performing the same operation multiple times with different inputs. So we have, for example, we have an input n. We're going to solve the problem from n to 1. So we decrease the value of n by 1 until we get 1. And then afterwards, we're going to um, summarize or add up all the values from 1 to n to get the whole solution. Okay. And in every step, we try smaller input to make the problem smaller. So what I have stated, so from n, we solve the problem, and then minus 1, we solve the problem until we get to 1. And then sum all everything to get the holistic result. Okay. And base condition is needed to stop the recursion. So we need to have a limit. We need to define what is the limitation of our algorithm so that we could stop the loop. Okay, so these are the three properties of a recursion. Again, we have a function that we use multiple times. We have values that will terminate the loop, and these values will be used to solve problems. Okay, we deduct, we reduce by a value of 1 or a certain value until n is equal to 1, and then we go back from 1 to n to solve the whole problem. Okay, so what is the difference between recursion and iteration? Both are using loop. Okay, so what are the difference between the two? So first, recursion refers to a situation where a function calls itself again and again until some condition is not reached. Until it's still true, we repeat this recursion algorithm. While for iteration refers to a situation where some statements are executed again and again using loops until some condition is true. So when we met this condition true, then the loop will stop. And we use stack for our for storing our data in recursion. Okay, so every step of our solution will be stored in that stack. Okay, since for each time we use the function, it will store the result because later we're going to combine it. Okay, and then for iteration, it doesn't use stack for solving. Okay, so it is stored in a variable. It is always updated. Okay, when we iterate, it is stored in specific variable. And in recursion, size of code is comparatively smaller in recursion. Okay, fewer lines compared with iteration. Okay, and recursion is always applied to a function, but in iteration, it always applied in a loop. Will it be a function or others, or other way of doing the loop? And the problem with recursion, it's slow in execution, even though we have smaller number of lines, but execution is slower compared with the iteration. And not all problems could be implemented using recursive solution. Unlike in iteration, there are more. Okay, you could solve it using iterative algorithm, and all recursive solution could be implemented using iterative method. And it is less efficient in terms of memory utilization and execution speed. Going back from the previous slide, we store each step. We store the output of each step in recursion. So that is why memory utilization is less efficient. While in iteration, it's more efficient because we have the specific variable that holds everything. Okay. And this is the comparison between the first, the recursion coding and the iteration coding. And as you can see here, this has a smaller number of lines compared with the iteration. And we use this function to call, okay, to determine what will happen for each step, okay? So as you can see here, we start with n, and then we call the fact, this function, n minus 1 until we get a value of 1. We stop it, okay? And this is the iteration. We have a loop here, and until this is false, okay? Until this statement is true, we stop the iteration, okay? So what are the advantages of recursion or recursive algorithm? So based on the previous slide, the code may be easier to write, lesser number of lines. 2, to solve such problems which are not really recursive, such as Tower of Hanoi. So there are problems that it is better to be solved using recursive because it is a recursive problem. Okay, and it could reduce unnecessary calling of a function or of other function. So we just call the same function every time we solve the problem. And fourth, extremely useful when applying the same solution. Okay, if we have the same problem, we could use this. We could use the other solution with that. And fifth, recursion reduces the length of code, same as with the first. It is very useful in solving the data structure problem. So you already discussed this in data struct, and one approach in solving issues with data structure is using recursive. And we are using infix, prefix, and postfix evaluation. So we could have different prefix and the different ways of storing our data in stacks. Okay, but the disadvantages are recursive functions are generally slower than non-recursive. Okay, slower again compared with iterative, with loop. Okay, it may require a lot of memory space to hold intermediate result. Again, each step are stored. So that's why we need a lot of space. If we have 1 million steps, so we need 1 million space for each. Okay, hard to analyze or understand the code. It is not more efficient in terms of space and time complexity, definitely, because it is slower and it needs more space. Okay, and there will be instances we're going to have may we may run out of memory because we have lots of instances. Okay, we need to store lots of data. So that's the main problem with the recursive algorithm. Okay, so how do we implement recursion? So first, we define a base case. What is our terminator? What is the value of how we're going to terminate our base? Okay. Second, recursive case. So what will be the property of the functions that we're going to call uh, as long we're going to call repeatedly, okay, as long as the base is not yet false. Okay. And third, we need to ensure the recursion terminates. Okay, don't forget that in every loop, even if it's non-recursive, it should terminate. The loop should terminate. It should not be an infinite loop. And then fourth, We combine the solution based on the recursive, based on the different cases, we combine it to have our solution for the original problem. Okay, so let's have an example. For example, we're going to solve a factorial of n, wherein n factorial is 1 times 2 times 3 up to times n. Okay, and for example, if we have factorial of 3, 3 times is equal to 1 times 2 times 3. So 3 is the maximum value that we multiply to our digits. So from 1, increment by 1 up to n, okay, is equal to the n factorial. So this is 643 factorial. Okay, so now let's apply recursive algorithm. So we need to define the base. So what will be the limiter? Okay, so n is equal to 1 when n is equal to 0 or 1. Okay, so that will be the stop. Okay, aside from the lower limit, n is also the upper limit. And for the recursive case, so the function that we're going to call, okay, is f function at n minus 1, okay, when n is greater than 1. So this function defines what will be the value that we're going to multiply with the previous value, okay? So again, this is our rules. So first, we start with n is equal to 3. So 3, so our formula for our factorial, so we need 3, the latest, times the second value. So function at 3 minus 1. But do we know the value of this? Not yet. So that's why we solve, okay, function at 2. So how do we solve function at 2? 2 times function 2 minus 1. So we still don't know what the value of function 2 minus 1. So we solve for function 1. And we know that function at 1 is equal to 1. So we already reached the limit, which is 1. So now we go to adding all the possible answers. Okay, so from 3 to 1, so we combine the solution here. So we start with 1, okay, then 2 times f1, so this will be 2, and then for f3, so 3 times function of 2, and the value of function of 2 is 2, so 3 times 2, 6. So we get the answer. So in the first part, again, from n going to 1, we don't know the value first, but we know the formula. And then after determining the base value, when we reach the base case, now we are ready to solve function 2, function 3. So just substitute the value until we get the value at function at 3. So that will be our final answer. Okay, so it's like reverse and then go forward. Okay, so that will be the end of recursive and non-recursive. So thank you for listening.